All right, let's talk about something you've probably walked past 100 times without ever really seeing. The next time you're in a high-rise, a factory, or even just a shopping mall, I want you to look closer. Because hidden in plain sight is this invisible system, this carefully planned choreography that's designed for one reason: to save your life. Today, we're going to unlock that system. We're diving deep into India's IS 13416 framework for emergency evacuation. So, safety engineers love this analogy. They see a building's escape route, the doors, the hallways, the stairs, like a single connected system. If you have a bottleneck anywhere, the whole thing can fail. But here's the twist. People aren't water. We panic. We get confused. We try to help each other. And that's exactly why the engineering has to be so much smarter than just simple fluid dynamics. And hey, if you're into this kind of stuff, these deep dives into the hidden engineering that keeps us safe, do us a huge favor and like, share, and subscribe to ISO Automation Labs. We live for breaking down these complex standards for you.
Okay, so let's start with the most important question of all. Why? Why does this whole complex framework even need to exist? Well, the answer, unfortunately, is often written in tragedy.
Every single rule, every calculation, and every standard we're about to talk about is basically a lesson learned the hard way. These are not just bureaucratic checklists. They are a powerful, proactive tool, a firewall against disaster, designed to make sure that when things go very wrong, people can get out safe and sound.
And this really gets at a massive shift in how we think about safety. It used to be just reactive, having a fire extinguisher to put out a fire once it starts. But modern safety engineering, it's completely proactive. It's this incredible discipline that blends building design, fluid dynamics, and, human psychology to build safety right into the bones of a building from day one.
Which brings us to the star of our show today, Indian Standard 13416. This is the bedrock, the foundation of modern safety planning, especially for workplaces and construction sites in India. So what is it, really?
Well, simply put, IS 13416 is a super comprehensive set of recommendations from the Bureau of Indian Standards. It's all about managing hazards in the workplace with a huge focus on those really high-risk environments, like construction sites and industrial plants where the dangers are changing all the time.
Now, the framework isn't just one giant document. It's broken down into 5 parts, each tackling a different kind of risk. You've got rules for falling materials, for preventing falls, even for how to dispose of debris safely. But the one we're really focusing on today, the absolute heart of evacuation planning, is Part 5, Fire Protection. Okay, this is where the math comes in, and it's super important. Before you can plan an escape, you have to know how many people you're planning for. That's called occupant load, and it's not a guess, it's a precise calculation. You take the floor area and you divide it by a specific factor from the code. An office might be 100 square feet per person, but a packed concert hall could be as low as 5. That single number changes everything. How many exits you need, how wide they are, the whole shebang.
But, a brilliant plan is completely useless if there's no one to actually execute it. So that brings us to the human element, the people who make a safety plan come alive.
A great evacuation plan works like a well-rehearsed team. You've got your site engineer, who's the link to the fire department. The fire safety officer, or FSO, they're the brains of the operation, the one writing the plan. Then you have the fire wardens, the leaders on the ground when an emergency hits. Every single role is crucial, right down to the security guards watching the site at night. It absolutely has to be a team effort.
All right, so we've covered the why and the who. Now let's get into the fun stuff, the how. This is all about the physical nuts and bolts, the engineering that actually creates a safe path out of a building.
This right here is the golden rule of egress design. It sounds simple, right? From wherever you are standing, there must be a clear, unbroken, and totally obvious path to safety. No boxes in the hallway, no chain doors, no confusing dead ends. It has to be continuous and unobstructed, period. And these standards get incredibly specific. Look at this, 7 feet, 6 inches. That's about 2.3 meters. It's the absolute minimum ceiling height allowed in an exit route. It might seem random, but it's there to make sure nothing, not a low-hanging sign or a pipe, can possibly slow people down or create a jam when every single second is critical. And here's another number that literally shapes buildings, 75 feet, or about 23 meters. In a typical industrial building that doesn't have sprinklers, you can never be more than 75 feet away from an exit.
Just think about that for a second. That one rule dictates how big rooms can be, where hallways go, and how many doors a building needs. It's a core principle of the architecture itself, all in the name of speed.
And all these little details work together. You've seen them a million times. Doors swing outward so a crowd pushing on them doesn't trap everyone inside. You have those push bars on exits in malls and theaters. That's panic hardware, so you don't have to fiddle with a knob. And of course, you've got the glowing exit signs and backup emergency lighting to guide you even if the power cuts out.
So, we've got the math figured out and the physical design in place, but how do you make sure it all actually works when it counts? Well, that's all about putting the plan into practice. Because let's be honest, a fire safety plan that's just sitting in a binder on a shelf is basically useless, right? The real work starts when you turn that document into action. And how do you do that? Through constant assessment and a whole lot of practice. It's all done through a systematic fire risk assessment, which is this continuous 5-step cycle. First, you identify the hazards. Then you figure out who's at risk. Then you work to reduce those risks. Step 4, you write it all down, make a plan, and train everyone. And the most important step, number 5, you constantly review and update it. Safety is never, ever a one-and-done kind of thing. And that brings us to the final, absolutely critical piece of the puzzle: mock drills. Drills build muscle memory. They turn confusion and hesitation into automatic, decisive action. In a real emergency, when your brain is screaming panic, that drilled-in response is what actually saves lives. It's what turns a piece of paper into a life-saving reflex. You know, understanding how these frameworks operate is really the key to building a safer world for all of us. So if you want to see more explainers just like this one, please take a second to like, share, and subscribe to ISO Automation Labs. It really helps us out. So I'll leave you with this. The next time you're out and about, look for those glowing exit signs. Notice how wide the hallways are. See where the fire extinguishers are placed. Will you just see a building? Or will you now see the invisible system, the brilliant framework of standards like IS 13416, all designed with one single purpose: to get you out safely?